Welcome to Fun with Binomial Probabilities, the Binomial Probability Worksheet. And I am going to go over, I think I'll start with 8 and 9, and we'll see how many of these we could do. Number 8 gives us an N and a P. And then it kind of, what does it say for X here? Now, here's the formula, but I am going to show how to use the calculator. This says, find the probability at least 3 successes. And we do want to think about what that means. So X is at least 3. So that means it is 3 or bigger, greater than or equal to 3. And what that really is, if you were looking at the distribution here, all the different possibilities that X could be. Of course, you could have 0 of them, right? You could have 1, you could have 2, you could have 3. You could have 4, you could have 5, you could have 6. And then there is an entire distribution for this. Let me show on the calculator how to see the entire distribution. And then what is this problem asking for? It's asking for this part of the list, which the calculator doesn't actually do. So the online calculators, you can type in greater than or equal to. So here's our friend, the TI84 plus. We are going to use this wonderful function right here, distribution. Let's get you in the spotlight here. So we do second vars, variables, to get the distributions. You'll see quite a list there. To introduce the first 3 are normal distributions. T is very important. It's also a bell curve normal shape, but a little bit wider. Chi-squared, F, usually not used in prob stats. And then we get to binomial. You'll see 2 of them here. PDF is for an exact X. These letters stand for probability distribution function and a cumulative distribution function. I mean, they're both probabilities, but cumulative would actually add up a certain amount of the list. Let's do actually the entire distribution, and the best way maybe to show this is in a list. So I will, first of all, clear this. In this list, I'm just going to put, I'm going to rebuild this list. And you may have reason to do this for some problem. Well, if it asked you to show the entire distribution, you wouldn't have to calculate these one by one. So here I've just put 0 to 6. Those are all the possibilities when I have 6 trials. I could have 0 successes, I could have all 6 successes. And in L2 here, I'm actually going to put the second vars. I'm going to go up to get to my binomial PDF. And it'll ask you for the number of trials, which is N. It'll ask you for the probability, which is 35%. And then here, instead of asking for, or giving it one value, I'm going to tell it to use L1. But that means I'm going to put in 0, I'm going to put in 1, I'm going to put in 2, and it's going to give me all those things. And I can just hit enter, and boom, just like that, it can calculate 7 probabilities in less than a second. So here is the probability distribution. You would expect 0.35 times 6 to be close to 2, right? So the mean is close to 2, and sure enough, there's the high number. And it is, what would you call that? Right skewed, because it has a tail going off to the right, and kind of lumpy or an accumulation over on the left. Well, I don't feel the need to write all those down. You can just imagine those numbers right there on that list. Well, I do this, and I'm taking up, 4 minutes of video to show you this list, to tell you what the cumulative function does. The cumulative function, and we are going to use CDF to solve this problem. We're going to use the binomial CDF, and when you do calculator work on the homework, it's good to do what I'm doing right here. We'll put in 6, we'll put in 35%, and then we're going to put in 2. Why would I do that? Why would I do that? Because it's going to add up these probabilities right here, and then we're going to take the complement. So it turns out that 1 minus this will be the probability that we're looking for. This is the I'll just keep going off to the left here. The probability that x is at least 3 is the complement of the probability that x is no more than 2. See if that makes sense to you. That's the probability, I guess we'll put it this way, that x is less than 3. And the binomial CDF function will do that for us. So let's just go over, let's get out of here. We do second vars. On my calculator at least it's B for CDF. I'm going to put in 6, 35%, and 2 because that's less than 3, discrete data, and I get that number. That is the probability of it being less than 3, and then I can do 1 minus, go back up, grab that number, and get the complement of being, how many decimals should we go out here? Maybe that. Now if you've already done this by hand and added up these 4 numbers, you should have gotten 35.3. And now maybe let's just double check that. We'll check our list here. Whoops, that's not what I wanted. Stat, edit lists. So that is actually adding up these numbers, right? 23, I said I wasn't going to do this. See how I am? 0951. There's already 33%. Here's another 30, so that gets us to 35%, and then there's just some tiny little scraggly 10 thousandths there. So that gets us to 35.3. But I find this way pretty quick. Now let's take a look at no more than 3. You don't have to do this complement trick when it's less than or equal to, because that's what the CDF function is doing. So number 9 says this is 100, this is 1%, and then the probability, well, I should just write down x. X is no more than 3. So what is that? Well, it's 3 or less, no more than 3. And I like to do this list. Of course, I won't number this all the way to 100, but we could think about the first 5 possibilities here. Where are we cutting off this distribution here? Wow, messy tonight. No more than 3, right? So no more than 3. Well, the CDF function will add up those probabilities for us. So let's take a look at how that works on the calculator. Second vars for distribution. You could type in the letter B if you can find the alphabet on here. What is that? It's the green B there. We change this to 100. We change this to 1%. We change that to, and I like to draw this chart just to make sure, especially if it were a test, be like, wait a minute, what am I talking about? No more than 3. Yeah, I'm going to include 3, right? But I'm going to stop there. Don't take the complement of this number. Oh, and I've done this in a weird place, so this is, oh geez, I should have gotten out of there. Okay. Rewind, record. Numbers are still there, that's good. There we go. 98%. And does that make sense? Well, the mean is 1, right? N times P is 1, so yeah, that doesn't bother me that that's such a huge number. The probability that X was not more than 3 is 0982. Okay, well, let's not make this video too long, but I think I have time to do number 10, and I can break it off into a second video if we want to do more here. So number 10, in a history class, Colin and Diana, oh, it's so British, they're writing a quiz. Who wrote this question? There are 10 questions. Well, guess what? That means 10 chances to guess, 10 trials. I don't recommend this, by the way. Each question has 5 possible answers. So guess what? 5 possible answers. If only one of them is right, you have a 20% chance of success, successfully guessing. And poor Colin, or is it Colin? Colin is going to he is going to guess on each of these. And what is passing? Each question at 5. Does it say passing? Did I read the question? Colin will pass the test if he guesses an answer to each question. Oh, yeah, again, who wrote this question? Because there's no definition of passing. Well, I guess you get to make it up. Is passing 50%? Is passing, I think, 60%. Huh? So that means he needs to get not exactly 6, but 6 or more. 6 or more. So what are we going to do? What are you going to do? Well, you are going to put in the old probability of, we'll put this into the calculator, but then we're, yeah, what do I want to do? Think before you write. We actually are going to ask our calculator to do this number, because the CDF function can do that for us. All right, and remember, less than 6 will not include 6. I know that sounds like a no-brainer, but we've got 6 there, but we're actually going to put 5 into our calculator. So let's try it. Also, you want to see a neat trick? Instead of looking it up on the menu, I can just go up to this old problem. If this works, if you have a plus, TI84 with nothing else behind it, and a TI83, I don't think can do this trick, but it's a lazy man's trick. Now I've got it already, and I can edit it. I can move my cursor. My n was 10, so I can just delete that. I'm changing this to 20%. And where did I say I was going to stop? Okay, not at 6, but at 5. Boom. Again, I always ask myself, does that make sense? Let's see. 99%? Well, what do we expect? The mean is 5, so a lot of the probability will be around 3, 4, 5. No, what am I saying? 0.2 times 10 is not 5. 0.2 times 10 is 2. So the mean is 2, and so the highest probabilities are going to be about around 1, 2, and 3. Nobody's guessing. Colin, give it up. You're not going to pass this quiz. It's 1 minus that number. Your chance of passing this by guessing is less than 1%. 0.00. And that is, as a teacher, I can say that is how it should be. 0, 0. You want to guess on my multiple choice with 5 choices? Be my guest. 6, 3, 7. That's pretty precise, but he just needs to know he has less than a 1% chance of passing. Okay, and then Diana, she's studied. So of course studying is going to greatly increase your chances. So let's try this problem now, replacing this with 75%. And I am going to, I just love this shortcut that a student actually showed me. Once I learned it, it changed my life. I'm just copying this. I've got all those numbers already there. I'm just changing this to 75. It's still passing, right? So anything, basically this is the probability of failing, less than a 6. And then we're going to take the complement of that. Oh, Diana, good news. Good news. You have a 92% chance. What have we learned here, kids? It pays to study. What is that? 2, I guess. Okay, well, let me cut this video short here, and we'll take a look at 11, 12, and 13 in the next.